This is Trisha with Insectopia, with another class. I love that you guys all come and join me. I was chatting in the box about what we might want to start for class today, and I didn't get a super great answer. So I was looking at the insects that I have, and I thought that we could look at this lined June beetle. It's really awesome because it has these amazing antennae. And then we'll be able to look at it. Now, it's a pretty large beetle. So when I put it under my desk camera, let's see. Pretty large beetle. I'm going to go ahead and put a ruler up here so that you can see. If we were going to measure our beetle in centimeters, it looks like the one that we're going to be drawing today, it's in the genus Polyphylla, and looks like it's about 3.7 or 3.8 centimeters. And you cannot see, you can't see that type of distance all at the same time under my microscope. So actually the view that you see here of the front of the head is as far away as we can get on the microscope. So we're going to have to kind of pull the specimen onto the board. You can press the print screen button and paste the picture of your beetle into another program if you want to have an idea of the entire insect all at once. Yeah, so let's get going. In the American Southwest, a lot of times you hear about the 10-lined June beetle, the 10-lined June beetle. The 10-lined June beetle has a really easy scientific name to remember. So it's Polyphylla, and then it's Decim lineata. So, decim lineata literally means 10 lines. So, when we're talking about the 10-lined June beetle, it makes sense that decim lineata is the epithet. Now, Polyphylla, poly meaning lots or many, and phylla in this spelling actually refers to, I believe it refers to plants. So phylla can be either they can be based in two different languages, and it can either mean plants or it can mean loving. And in this case, it's Polyphylla, meaning like many plants, because the June beetles, they don't feed on any one specific plants. They're this really large generalist. Now, let me make sure I spelled Polyphylla right. Yes, I did. All right, deal. Good. All right, so, Polyphylla decim lineata. But that species, that's the one that we always hear about, and that is this little guy right here, over to the right. That's Polyphylla decim lineata. And both specimens I have of that species, they don't have their antenna open and spread and beautiful. And so we could look at those, but I'd rather look at the awesome antenna. So the one that we're going to be sketching today is not the 10-lined June beetle, but it's in the same genus. And all of the beetles in this genus are called lined June beetles. Because this guy over here on the right, he's the 10-lined June beetle. He's got 10 lines. All of the other ones in the same genus, they all have long lines, but they're different species. They won't interbreed, those types of things. So, very good. So on the top here, I'm going to start my sketch with lined June beetle. And we do know that it's in that genus Polyphylla. And I'm not sure what species it is. I probably could look it up. Well, look how fluffy that one is. There's a really fluffy lined June beetle. All right, so there's no way I'm going to be able to identify it for you at this very moment, because there are too many species in the genus of Polyphylla for me to confirm without using an actual key. But at least we got to the genus. That's pretty good. So where did my... There it is. Polyphylla sp. All right, so I'm going to go ahead and pull our specimen over here underneath my desk camera microscope, so that if you would like to take a screenshot of our beetle friend here, so you have all of oops, you can see the edge of the magic. No one wants to see the edge of the magic. All right. It is actually a really pretty red-brown color. The lighting right here on this beetle isn't being the best. It's not brightening up. But it's actually, the true color is actually more correct on the microscope in this circumstance. So when we go back and we're looking at the beetle underneath the microscope, you'll see that you'll see its true colors shining through. All right, let's see. Very good. All right, for me, I think I'm going to hold the beetle over here so that I can get the size of our friend. So maybe if I keep it on the edge of the paper, you'll be able to see half of them as we're going along. All right. So the head, you can already see a little bit from the microscope image. Keep in mind when we're looking at our specimen, the head is significantly smaller than the pronotum or the elytra. And so when you're making the approximate size on your paper, keep in mind that your head is not going to be too large in comparison. I'm going to try and make mine a little bit more even in the center of my paper. And then we also need space for those amazing antennae. I believe they're called lamellet antenna. Let me go and look it up just to make sure. Yes. Yep. So when you're seeing antennae like this, where they've got these long, what look like, I don't know, fans. These are like fan-like antenna. They actually have the ability to close and almost look like a club, and then when they open, they fan out. And we call them lamellate antenna. Antennae? All right. So we've got the head here. We're just doing the very light outline, so I'm going to give myself a little bit of space for the eyes here. And then it almost looks like he has a scoop upper lip, but that's actually what we call in beetles, we call that the clypeus. It's spelled C-L-Y-P-E-U-S, if you are curious about that. I'll probably write that one down when we're getting our final outline taken care of. So we've got the head space, we have the clypeus here. I know that my antennae are going to be coming out from right about here, so maybe in this specimen I'll just give myself kind of the base of where it's going to come out. And I do imagine that I should have enough space, but I might be going into some of these letters up here. So we'll see what happens. After getting the head kind of lightly sketched out, the pronotum is this kind of wide triangular shape. So it's narrow at the top, it gets wider. And this is just a really, really rough start to kind of get our outline for our insect taken care of. And then we're going to be zooming in and making sure that all the lines are right. So keep this first sketch really light. All right, let's see. So June beetles are in a subfamily of scarab beetles. So a lot of times when people think of scarab beetles, they only think of like scarab beetles in Egypt. And funny enough, scarab beetles in Egypt are dung beetles. At least the ones that they talk about when you're talking about like ancient Egyptian cultures, scarabs, those were dung beetles, which is a subfamily of scarabs. There are lots and lots of different types. June beetles are one. Rose chafers are another subfamily of scarab beetles. Dung beetles. Alright, on the center line of our beetle here, we're going to have a scutellum. This is between the elytra, right here. And then we have the whole elytra. So the left and the right one, these are the front wings of our beetles. So you can see that beetles have that really hard outer shell and then soft membranous wings underneath. These hard outer shells are called elytra. Elytra is the plural word for elytron, if you were talking about a single elytron on one side or the other, the left elytron. But 90% of the time in insect keys, they talk about them together. They describe the elytra as almost a whole because insects are symmetrical. So whatever's on the left side should, in theory, be on the right side. And if they're talking about a certain number of spots, if those numbers of spots are random, then you wouldn't be talking about it in a key. So, a lot of times, you don't even hear the word elytron. And for me, it even sounds weird to say it, even though I know that that's the singular form. Alright, I'm just going to kind of continue this angle out a little bit, and then run a parallel line here. Until we get to the end, and then the end is fairly blunt for the elytra. And we can see a little bit of the abdomen coming out from behind the elytra. I'm not sure if we're going to be able to see that when we're looking at it from a completely dorsal point of view, but I think we probably will. So I'm going to add just a little bit of the end of the abdomen. You probably can see it past the elytra. Alright, so we're getting an outline started. We do need to get the approximate length of the legs in there. The front legs up here are going to be coming out from what looks like the back of the pronotum. Comes out like this. And then the tibia is going to be coming up and the tarsi are going to be coming out, something like that. I'm just giving myself rough outlines. The middle legs are connected in this region here, and the femur is going to be really short coming out this way because it's mostly coming up towards the camera and then down and out. And the hind legs, we're going to take them out from about here. And then tibia, and then tarsi. I might even make the tarsal segments should be rounded in this species, so I rounded them out just a little bit. And then obviously the elytra are separated, so central line, looking good. Alright, so we have a very basic outline of our lined June beetle here. And I'm excited to get a better kind of zoomed in look at this head. So I'm going to turn this sketch off really quick, and we're going to play with the microscope for a minute. Before we get to the antenna, I want to see the head and the head shape and the eyes. A lot of species of beetles that live in Arizona, this one was collected in Arizona. A lot of species of beetles that live in Arizona, yes, they have what look like long eyelashes, or they have long hairs around their compound eyes. Now, that is an adaptation that they have because they live in the desert. So it helps them kind of keep the sand off of their eyes. Having long eyelashes to kind of, and obviously the eyelashes don't blink like that, but when you have those hairs there, it does kind of protect the lenses because the sand will get stuck in the hairs first. It looks like she also might have long hairs on the base of her antennae, so that she can probably clear her eyes off too. That's really kind of cute. All right, so I'm gonna get some of this sketch taken care of. Let's see. This one's gonna be pretty detailed because she has a lot of long features, so her head's gonna be kind of small in comparison. But let's see what happens. So I liked the approximate size of my head, but I got those light lines out of my way so I won't have to erase them later. Instead of having the line go convex like that, I'm actually going to take it and bring it concave. And that's going to be inside of the eyes. Alright, so it's kind of like you're almost making the little eye socket that the eyes are going to go into. Now, that means it also has to go all the way around to the front. Okay, and then it looks like, let me go ahead and look at it under the microscope for a moment. Yeah, there's this W shape here. So instead of having the head connect directly to the pronotum in this really pretty straight line, it has more of this wave pattern where right after the eyes are connected, it kind of comes up and then back down in this little wave. And so that is going to give you a little bit of definition between the head and the pronotum here. Coming up in front, I'm going to come up straight just a little bit. That's going to give myself the connection for the antenna. And we're trying to keep everything symmetrical along the center line. It looks like my left side got a little bit wonky. Okay, and then we came up, very good, and then that front dish-like thing, it almost looks like they took their front lip and expanded it really long, but it's not the labrum. That's actually what we call the clypeus. Let's see. So after our head shape kind of came inward, this is where the antennae are going to be connected. It does get a little bit wider before it narrows off and kind of turns into this little plate. It's kind of cute. It's got such an adorable head. All right. There is a little bit of a separation here. So right after... It is two separate plates, so you can go ahead and separate those if you'd like. I am going to come back in and add the eyes here and here, and they're going to connect just inside of that line. A lot of times when we are sketching compound eyes, I tell you to make sure that they kind of bulge out away from the edge of our headline, but today you want it kind of underneath because we're going to be putting in those really pretty long hairs around its eyes. And then as long as those hairs, so we're starting from the bottom of that socket and kind of working them up, and then at the top and working down. And it'll give you some of these nice long pretty, I like that side, nice long pretty hairs. Work. They said, "You're trying to get at me too close." Anyway. Alright, so something like that. Now, our beetle, the lion's June beetle, doesn't have any ocelli. It doesn't have any simple eyes. You can see that it does have a very unique first segment of the antenna. So I mentioned that the antennal type as a whole, are called lamellate, but I didn't tell you what the names of the antennal segments are. So, let's go ahead and take a minute and check out these antennae because they are awesome. And we're going to make these words fit. There we go. So there. Sometimes they don't want to fit and we just have to force them. They're so cool. Alright, so we have three names for our antennal segments. The first antennal segment, that's that kind of bulbous one. Let's get Terry out, he can help us. It's this one right here, that's the scape. So it's kind of thin at the base, it kind of gets longer and it's bulbous, and it has this really thick yellow hair. I think that that's really cool. I believe it's for cleaning the eye off. That's what makes sense to me. But it's awesome that it's there. The pedicel is the next segment. It's right here. And then all of the other segments from 3 to the end, these are all segments of the flagellum. And every single one of these comb-like pieces connects to an individual segment of the antenna. So we could count them. 1, 2, 3, 4, 5. And then you count these 6, 7, 8. I do believe he has 8 antennal segments, but I could go ahead and ask. I believe all scarab beetles have the same number of antennal segments. Hi, Lemmy. Yeah, they're supposed to have 10. That's what I thought. Hi, Lemmy. He is saying, "I want lunchtime." He says, "Food? Food? Lemmy, you can't hang out with the live stream. I'm trying to draw." Thank you. Lemmy. All right, so I'm gonna start this. I'm gonna start this antennal segment. And funny enough, I can't see my hand, but I can see my computer screen. So let's see if we can draw with Lemmy in the way. Bud. No, I can do this. I know. Okay, you're gonna have to give me a moment. We're gonna have to put Lemmy in another room. Say hi, Lemmy. Bye, Lemmy. We love you. Misty upstairs. Love you, buddy. Please don't hurt my kitty. All right, we're back. Mr. Lemmy there. Cats know best, you know? Alright, so here's where we're going to be starting our antennal segment. It's nice and narrow at the base. It kind of gets wider and becomes this little teardroppy antennal segment. And it's maybe a little bit... No, it's actually about the same size as the eye, which is kind of funny. I was going to say that it was a little bigger, but it's about the same. Ouch. There we go. And it had those long hairs coming in this direction, so I want to make sure those get on there. Then we have the pedicel. Generally is a smaller segment because it helps with kind of the flexibility in the antenna type stuff. You want the next segment to be really small to help it all kind of move smoothly. So that is 1, 2. And then the next one is the last kind of normal segment. Now, June beetles are scarab beetles, so they should have 10 antennal segments, which is what I thought. And then we had counted like 8. So we're going to have to find where the other 2 antennal segments are, because I know that they exist. And that's one of those things that they put them in keys because it should be easy to count, right? Should be really easy to count the number of antennal segments, but sometimes looking at a specimen, you'll accidentally miss one segment over and over. Oh, welcome, Susan! It wanted to hiss at you. Yeah, they do that. They, I believe that hissing noise is made by rubbing the top of their abdomen against the bottom of their elytra. I believe that's where it comes from. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our miscounting wasn't in the base of our antennal segments, but that 2 of them are actually still stuck together. So I had counted 1, 2, 3, 4, 5, but it's actually 2 here. 1, 2, 3, 4, and then this one is 5, 6, 7. And that's 8, 9, 10. So those are our 10 antennal segments. And actually, if you were calling them you would call this segment right here, you would call them A4 through 10. Yeah, because you count from the base of the head to the end of the antenna. Didn't stop me from pulling it out of the tree and sketching it. I love that. Well, these beetles are herbivorous, right? So they're not actually going to hurt you or anything. They make loud hissing noises. And if you do let them, like, walk on you, their tarsal claws that we're going to be seeing a little bit later, those are pretty sharp. So they can hold on to you really, really tight with those. So let's see. I'm going to give myself some nice long antennal segments that look like they could fold into one another. Now, I have not sketched lamellate antenna in a long time. So let's see how well I do. The end of every segment, let's see if I can, yeah, there we go. The end of every segment ends in like a little cup. Maybe I can just zoom in and show you that. There are some things I can describe to you, and some things that I think are better off seen. So what's important about these antennal segments is right here at the end. Excuse Excuse me. All right, we're better. So, if we look... Yes, like spoons with very long handles. I love that description, exactly. So this first segment right here, it starts kind of way down here and it scoops up and then goes out. And each one of these segments are like that. They have this little scoop. And so that gives them the ability to perfectly stack onto one another. And you can see that with these two segments here. With segments, this one's 4, so these are 5 and 6. With segments 5 and 6 here, they're still completely together. And so are 9 and 10. But at the very end, instead of it being scooped up, the spoon is scooped down. So it gives a kind of like a little, almost like a little book. I don't know. It stacks on top of each other like that. So this long one here is actually long and scooped in the other direction. Alright. And now that we've seen that, I might just change mine a little bit too, because I had the image a little bit sharper in my mind. But these segments are really nice and smooth, which is cool. Alright, so 1... 2, 1, 2, 3, 4, 2, 3, 4, 5, 6, 7. I need 3 more. 8, 9. I think that they could use a little bit of help in this region, but they're a pretty good example of what we're looking at, right? So we are looking at these lamellate antennae. And many beetles, many scarab beetles have lamellate antenna, but not all of them have it to this extreme. So there are some beetles that it looks like they have just a little club on the end of their antenna, just like a little circle. And then it can open up and it might open into 3 segments. And those guys are also really cute. I've seen some dung beetles with that type of antenna, where their antenna are 3 and they open up and wiggle around. They're so cute. So I think that gives us the antenna and the head, and we got the eyes. So moving back down to the pronotum. Now, Susan, I did want to show you one thing. So I'm going to lock this image in, and I'm going to show you something. So in Arizona, there are actually many beetles in this genus. The genus is Polyphylla. But the most common lined scarab beetle out in Arizona is the 10-lined scarab. They look like this right here, and they're the species Polyphylla decimlineata. This one, the one that we're drawing, is actually a different species. Even though it's in the same genus, it's found in the same region. It's beautiful and lined also. So it would be super duper cool if you were seeing these really big lined June beetles. They look about like 70% larger than the 10-lined June beetle. They're really awesome to see around. But it's probably a little bit more likely that you are seeing the 10-lined June beetle, this one over here on the right. Oh, and we're going to have to flip it upside down so I can show you its fluffy tummy. It's so fluffy. Yeah, that's what I thought. So I figured I would share that with you. So we call them all in this genus Polyphylla. We call them all the lined June beetles. And it's just that one species that's the 10-lined. Oh, cool. Yeah, very good, Susan. So you may have seen the difference when we got down to the pronotum and the elytra, because this species doesn't have 10 lines, but I'm glad we were able to clear it up. Alright, so I got rid of this line in the head. Let's go ahead and get our pronotum taken care of. You thought the 10 was just missing. I understand that. Alright, so the pronotum is going to arch out just a little bit, but instead of cutting straight across like we did in our first illustration, in our first sketch through, we're going to give it that really strong arch that's going to be pretty low in the very center. So I'm going to get rid of the scutellum that we sketched, because it's going to be much, much lower. So we've got the pronotal edge that just arches out a little bit, and it is separated from the head. It's not a whole lot, but you can make sure that there's a little bit of an angle there. And then it widens out. I call this, when I'm doing this with kids, I say it's kind of like 2 parentheses. Wide parentheses. And at this point, what I want to do is I'm going to imagine this line straight across on both specimens, and then I'm going to give myself a mark where I think the lowest point should be, right here in the center. And then that's the line that I'm going to aim for. And I'm going to erase the light line that I have here, because it's going to be a little bit in the way. So it comes up over that, and then it comes down. So is that about right? That's probably about right. And we got to do the same thing on the other side, and not bump the camera. Yeah, like that. Cool. All right, so that's going to be our pronotal shape. This is our pronotum. The first segment of the thorax. Before we go to legs, I want to finish the pronotum and the elytra, and then we'll do the legs. So I want to make sure that I've got at least these really pretty stripes down. So this one central stripe. Now with these June beetles, the stripes are not always all identical, but generally they'll have the same shapes. So when you're seeing these types of June beetles, the line may be wider, it may be narrower. There might even be like little patches or little holes in the line, like you can see over here to the left. There's a couple of regions that it's not white. There's that type of variation, but generally every species is going to have approximately the same marks. Like in the same regions, essentially. I don't know how to say that better. But for instance, like they're always going to have 3 lines on the pronotum, but some of those lines might be patchy. Okay. I like my right side better than my left side today. Okay. Yay! Alright, so we've got the pronotum taken care of. Let's go look and see what the elytra look like. You may have already addressed this, but what is the function of the sticky out blunt head shovel? Is it just for protection? So, I'm not sure. So I'll give you the name for it. I think that you may not have been here when we were talking about its name. That sticky out blunt head shield thing is called the clippius. It's this whole region up here. The clippius, the function of the clippius a lot of times is the connection between the head and the mouth. So in beetles, a lot of times the front of the head has like a little bit of clippius, and then you can see the labrum right underneath it. So it connects the mouth parts, one. But as of like a function as to like why it looks like a shovel, I'm not sure. The males and the females are both shaped that way, so I wouldn't say that it would be like a male thing fighting for territory or fighting for ladies. They do dig. So I guess it's possible that if functionally helps them to dig out, because when they're a grub, they're underground or they're in rotting wood, and then they pupate, and then after they pupate, they have to dig their way back out. A lot of them pupate in the ground, even if they were feeding on wood as grubs. They'll leave the log and dig down, and then when they're adults, they have to dig back up. So it's possible that it's for digging. It's also possible that it's to protect their food, but I'm not sure exactly how that would work. Just imagine that that's like a big, like, shield type thing on top of their mouth parts. And we'll go ahead and flip them over after we're done sketching, but you'll see that their mouth parts are pretty much like directly under them, right about here. So it could be something with eating, and it could be something with digging. Those are my guesses. All right, thank you. No problem, Susan. Okay. I was hoping to get the entire beetle under the microscope, but that's just not going to happen. It's too big. So, from this view, we can see the lines, and we can see some of those really fine white seedy. I think those are pretty. Let's zoom for a minute. Look how pretty they are. Those hairs might be gold rather than white. That's beautiful. So, this is what I was talking about, and I guess this is an answer to my question, because I've been looking at those colors thinking that they almost looked fluffy, that those colors may not actually be colors on the exoskeleton. They are not. Those are all fine hairs that make those stripes, which is why they can be random between specimens. So I was mentioning that sometimes these stripes, even though this is where they normally are, can be patchy or just kind of have holes all over them. And that's the reason is because they are actually hair. And they can get rubbed off. Maybe it's vain about its facial hair. That's hilarious, Susan. Or its back hair. I think it has beautiful back hair. Keep in mind that insect hair is called seedy. So all of that is beautiful seedy. And if a scientist was describing it, I would describe that yellow. I would describe that hair in the center gold. Yeah, you can scrape them off and see red underneath. Maybe we can look at a stripe that has that. Like this one. Yep, there you go. So there are a couple of spots in this on this stripe that got worn off, or that the hairs come off of, and you can see that it's completely red underneath. And there aren't any other hairs, right? So there's this stripe of white hairs, and then there's a region that's around them without any hair at all, and then that really pretty gold hair. The question is, does it have punctations too? They do have little dots, but I don't know if I would call them punctations or if I would call them hair follicles, because the little dots look like they're areas that either had hair or used to have hair. There might be a couple of extra spots right there in that clear region that have never had hair, but I think that if we look at a lot of, like, here, Terry will help me point, like this little circle there and this little circle there, I think that those used to have gold hair in them. So it might be a little mixture of both, but if I was using words to describe this beetle, I probably wouldn't call it punctate. I wouldn't say that it's covered in little punctations. It's cetose. It's covered in hair. So all of those little golden things that look like dots, those are actually little gold hairs. Makes me wonder what, if we zoomed in really close on the pronotum, what this edge would look like. Let's go look at it really quick. Because we're going to be sketching the scutellum next anyway. I was curious about the hairs. Yep, they're so pretty. If you ever shave your head, you're getting it dyed like this. That's great. Alright, so I guess what we'll do is I want to start the sketch of the elytra right here, looking up at just the top of the elytra, and then we'll move the specimen down so that we can see what the end looks like. Because the whole thing just won't fit underneath the microscope. Let's see. There is the scutellum, that's right here, and it's going to be this D-shaped, but I'm leaving a little bit of space in between the bottom of the pronotum and where I start my scutellum, because I want a little bit of space for that hair that I'm going to be adding in there. The little pretty gold hair. Alright, so I've got a scutellum taken care of. Now, the scutellum is going to, the edge of the elytra, I guess, they're going to be almost heart-shaped away from the scutellum. I kind of love that about this specimen. It has this very almost smooth heart shape, so I'll show you. Like, something. So your line is going to come round out and then come down, and then it's almost going to be nice and smooth in both directions. I like my left side better this time. Let's see what can happen with my right side. I think it just needs to round out a little bit lower. Very good. Alright, so there is a little bit of space in between the pronotum and the elytra, and so I'm just going to come back in here and fill it with short lines, little hairs that'll connect these guys. they do have a lot of seedy all over them, so it makes sense to give them a little bit extras around the corners anyway. Alright, so we've got that taken care of. The edges of the elytron round out, but then pretty much go parallel right away until they get to the end. So I'm going to round this out and just give my beetle a nice wide elytra. And I want to start some of the coloration here. So I have a central line that I gave myself in the beginning. I can just follow that down for the center. And then we've got... So this third line, I want to point this out. This center line lines with lines up with the central line on the pronotum, and then this third line lines up with the edge on the top, and this third line lines up. So this line is going to continue down, and you can just give yourself, you know, most of the way, but not all the way because we can't see the whole thing yet. And then there's a little bit of a white border that comes all the way up, and then where this one's going to be coming down, you've got another stripe of white seedy. And so you've got the same on the other side, this stripe of white seedy here. And then between those, you have a lighter line that doesn't ever reach the top, right? So more like this. But they are parallel with each other, the left and the right side. And our final line, we do have one more that reaches around the edges. This beetle looks so good with its stripes, with its lines. I just love it. The advantage of sketching a side view is you don't have to worry about symmetry. I hadn't thought of that. I love that. Maybe I'll have to draw a couple more lateral views. Alright, I believe this gives us everything that we need to finish the bottom of our sketch. We cannot see the abdomen from the dorsal view, so I'm just going to erase that out of there right now. I'm going to take these lines that are the darker ones, right? They're the ones that I trust. And I'm going to round them out. Let's see. I think that was about right, this one. Sometimes it takes me a time or two to make sure that I like the length of my abdomen, or the abdomen and the elytra, right? I like the end of my insect. Very good. Alright, so you can see it doesn't taper a lot, which is what I was trying to stop. I had that longer kind of tapered elytra, and I wanted to make sure that where they ended a little bit more blunt. So now we can see that these light stripes come all the way down the center of the elytra, but then, how cool is it? They kind of curl around. And I can see it from this angle too. They kind of curl around and they connect with this outer stripe. Oops. I connected the... So this outer stripe does kind of, well... It doesn't, there is always a brown border around the edge, so it does not reach all the way to the edge at any point, but it does follow around. like that. All right, and then I'm seeing 2 more ends, and that's correct. We have 2 more, and they don't touch the bottom, so they just come down like this, and they end. It's so pretty. And so it's funny because if you imagine like this white stripe here, if it's starting here, it comes up, goes around, hits this top edge, winds around the edge, comes down the center of the elytra, and then winds up and then passes itself and comes around. So this stripe here is all one stripe, and this little one here is the little island. All right, I'm going to lower my sketch a little bit so that you can see it all together. Oh, he's so pretty. All right, let's look at some legs. Now, the legs of these lined June beetles have huge tarsal claws. Microscope. Sometimes if the image gets too bright too quickly, it freaks out. So we are looking at the legs here. The femur is very, very short. It's almost impossible to see right there. The tibia is nice and long, and it's the guy that almost looks like it has an additional 2 spines on the outer side. That is for digging. And then it has those really long talon-like tarsal claws. And a lot of beetles in the American Southwest are going to have those really big tarsal claws, but I'm not sure why so large, because it's not like they're predators, so they have to hold on to plants, but I can't imagine that you'd have to hold on to plants that tight. I don't know. The June beetle should have a 5x5 tarsal formula, so we're going to have to zoom in and count and see where all 5 tarsal segments are. There might be a small one kind of hidden, so we'll be zooming in to check that out. So the femur comes back from right here in the end of the pronotum, and it's just a little guy here. You can't see him too much, but we know he's there. That's the femur. And then the tibia is going to be kind of rounded off here, and it's going to be moving up. Now, the inside of the tibia is nice and smooth, so we can just make it one individual line. But the outside of the tibia has one and then another one. 2 little kind of, I guess, those, I wouldn't call them spines either. I'm not sure what you would call them. But their purpose is for digging. And so that's going to be the femur and the tibia. And if we zoom in, I want to zoom in on the tarsal segments before we draw them. Okay. they do have 5 tarsal segments. And you can see them actually pretty well as long as you zoom in. There's 1, 2, 3, 4, and then 5. And those ginormous claws. So these ones are almost kind of rectangular shaped, and they do have little hairs coming out at the end of every tarsal segment. So the tarsal formula is going to be 5, 5, 5, which means we're going to see a couple more of these. Now, you can see that we have this little wave here on the end. It can also hide a tarsal segment, so it might be difficult to see all of them sometimes. Well, let's see. We've got 1, 2, 3, 4, and then the big one. 5. Pretty awesome. All right, let's look at the middle leg. Look at that hair on the inside of its middle leg. Right here. That is a lot of hair. I wonder if he's cleaning off his stomach, his underside, with that. I would imagine that you would want something that was more like a comb, something more solid than more hair to clean your hair, but maybe not. Now, I'm mistaken. The femur, instead of coming up here, is actually going to be coming down. So, if you start right about here at the corner of the elytra and just start a little femur coming out and kind of going down like this, then we're going to get all of our angles right. So, the tibia is going to go out, and we do have what looks like 2 spines on the outside, and then a lot of hair, seedy, on the inside. So let's see. 1 and 2. Lots of hair on the inside of it. And then we get to start the tarsal segments. So our tarsal segments, we should have 5 once again. 4 little rectangular segments. Let's count them. 1, 2, 3, 4, and then the one large one, 5. One, 2, 3, 4, and then the long one with the claws. Actually, they both should be facing towards its body. No. Well, I mean, actually, that doesn't look horrible. Alright, cool. That'll stay like that. Alright, so a lot of these subfamilies in here, a lot of June beetles are going to have really, really soft underbodies. It does, I'm not sure if they want it to, but when they are traveling from flower to flower to, like, collect nectar and yummy juices, they do get covered in pollen. So even though they may not purposely be pollinating, June beetles and other, like, flower-loving beetles do pollinate, especially when they're covered in hair. Oh, that's all right, Susan. I hope that everything's all right, and I'm glad that you're back. Just know that I've been talking to myself for a little bit of time, and that's okay. You can feel free to go back and watch my mental meanderings afterwards if you'd like. They must only be able to land on the biggest of flowers. I guess that's true. They are huge, heavy beetles. I always imagine them landing on things like honeysuckle, where it's not an individual flower. It's more like a flower on a bush, or like a flower on a shrub, or, you know, something that's a little bit more sturdy. I've seen other species of June beetles. Nope, that's a lie. I've seen species of flower chafers go and feed on, prickly pear cactus. They'll feed on the prickly pears when they're ripe and juicy, because they're a really good access to sugar, but I don't know if I've ever seen June beetles. June beetles do prefer to eat, like, vegetation and greens, but they will go and drink sugar from flowers and stuff, and the like. Yes, flowers with sturdy stems. Alright, sounds good. So, when we're looking at the... Ooh, check that out. It looks like the tibia has some pretty awesome tibial spurs. We might... Let's go and zoom in really quick. Yes, that is a fabulously cetos tibia. Exactly. I love that that's one of the things that you noticed, because it was one of the first things I noticed too. I was like, wow, it is so cetos. So we were discussing, or maybe I was discussing what the function of all that would be. My guess is to kind of wipe off of the abdomen. But yes, there are tibial spurs. Those two guys right here. One is closer to us than the other, so when we focus on one, the other one is a little blurry, but there are two tibial spurs, and at the end of every tarsal segment, there's a little bit of hair. I do wonder what the actual claw looks like when we zoom in on it, so let's go and see what that looks like before I finish my sketch. Okay, so that's one claw that you can see right here. It's a double. Do they have a risk of overheating? Yeah, it's a really awesome claw. So there are still two tarsal claws. It's just that each claw has two spines. So that's really cool. I'm not sure what word you would use to describe that. Or two-part claws. Yeah. You're wondering if the fluffiness could serve as an insulation to keep the sun off. I don't think so. It's, a lot of times long hairs around the eyes. We mentioned this before the antenna. So, these, hairs around the eyes are used to keep sand off of them. So it's possible that they're using these hairs to wipe the sand off of their wings or their bottom before they fly, because they keep these hairs up and around their face and their head. They almost look like they have eyelashes, because those hairs are going to actually help them keep the sand off of their eyes. So that's a possibility. Good for opening bottles. Now all we need to do is take the line June beetles to the tailgate. They just have hair around the eyes. Susan, have I not shown you hairy eyeballs yet? I actually have an insect next to me right now that has hairy eyeballs. We might have to pull that out in a minute. I'm going to add the femur here while we're talking. The femur is coming out, and then the tibia is going to come down. It looks like the outside is pretty smooth. There are 3 little, they almost look like hair-sized spines. They're very small. And then you've got the rest of the tibia and these really cool tibial spines. There's 2 of them. And then you have 4 square tarsal segments. 1, 2, 3, 4. And then you have this long 5th tarsal segment that's a little longer at the end. And these claws are double. So that's cool. I'm going to go ahead and add that. And maybe I'll try and see if I can add that to the first and second. I wonder if the second pair is doubled like that. Because we did zoom in on it. And I don't remember seeing it like that. Okay, yep, this one's doubled too. There's the double claw. And then 2 little hairs at the end of their tarsal at the end. No, I haven't seen them. I want hairy eyeballs. All right, so I can do that for you. All right, so I'm pretty happy with our beetle. Before I get you hairy eyeballs, I'm going to flip this beetle over and we're going to look at its underside. Because if you've been enjoying seeing the hair on the top, you're going to just like, this is awesome. Let's see if she'll stay. Look at that. Look at that hair. She's so fluffy. I absolutely love it. So that's what the bottom of the thorax looks like. The thorax is absolutely covered in long, gorgeous locks. Yeah. It's amazing. And actually, I believe I have a stacked microscope image of this. Let me go and grab it for us really quick. You want to squeeze it. Aww. Let's see. Here we go. It's a scarab. The 10-lined. Ah, so I took a picture of the fluff of the 10-lined. And that's what it looked like. I just love how fluffy they are. So either if you're looking at, this is actually the 10-lined hairs, or if we're looking at these guys, they just have absolutely beautiful long golden hair on their on the bottom side. Now their abdomen is a little more boring. Alright, it has those individual little hairs, but those hairs do give them kind of this really pretty striping along the edges of their abdominal segments. It also makes it really easy to count that they have 5. 1, 2, 3, 4, 5. It's the Lorax! That's genius. So the abdomen has some fine long hairs at the very end, right around here. Right here, they have some very fine long hairs, but But if you go kind of to the center, I don't think that the hairs are as long. Look how cute they are. But there are two forms of hairs. There are those really thin yellow ones, and then there's the thicker white ones that give that color, that stripe right there. Do you think people would listen better if this guy spoke for the trees? Aw, maybe. We can rename him the Lorax Beetle. All right, the other thing I wanted to see was the bottom side of the mouth, so that we could look at what to see if the Clypeus may have some fun function. That's just wild. The beetle is too big to manipulate in the ways that I normally manipulate them. So let me see if I can use a little bit of this. There. That might work. Tell him to stop moving. There we go, that's better. Ha! Screen pause. Alright, so we are looking at the mouth part, and you can see, well, there's a whole lot of things happening right here. I'm just going to use my microscope zoom so we can point some of this stuff out. This one. Let me look really quick. I want to make sure I'm pointing to the right part. It's like the orange part right there. Yeah, so these guys right here. Alright, so it's got to be these black parts right here. So right about here and here, we can see that it has, those are its mandibles. That's where I was trying to point out the mandibles first. So right here and here, those two dark areas, that's going to be kind of where our mandibles are. This piece up here, that's the upper lip, the labrum. Then underneath it, you have what we call the maxilla that has this palp and this palp. Those are like the mouth fingers. And then underneath the maxilla, you have the labrum. This is the bottom lip. And it also has labial palps. So you have two pairs of mouth fingers. You have maxillary palps on the top that are a little bit longer. And then you have labial palps on the bottom that are a little bit shorter. Oh, the eyes have a cool pattern. Yeah. I didn't zoom in on them, though, so I might as well go ahead and zoom in as far as we can and see what happens. Let's see what these eyes look like. Cool. They look like cheetah print. Yeah, they look like cheetah print. That's what I've decided. That's really, really cool. Yeah, that's, that gap in the middle is the actual mouth opening. opening. And so that's why I was trying to kind of angle it so we were looking directly into its mouth, because I wanted to see if we could see anything cool in there. Because when we looked at it from the bottom, I could see that its mandibles were a little bit open. And so that's kind of why I was trying to angle it out properly. But yes, that's what we were looking at, is we were looking at it pretty much inside of the mouth, and you could see into its mouth hole. Beetle's gotta be extra. Yeah, pretty much. So let me go ahead and get these. I have to get these labels back on the specimen. So this one was collected in Oak Creek, Arizona in 2010. For your data. That was the same year I picked up Acorn, my baby tarantula. She was really cute. Alright, let's look at a honeybee's eyes. Now, I have a really good picture of the honeybee's eyes that I will show you in a moment, but I figured we would just start with seeing what we could see this way first. I have collected a couple of pet tarantulas from the wild. The pet tarantula that I shared with this class is not from the wild. I don't have any wild-caught specimens right now. But I have wild-collected tarantulas for educational purposes. And that is a hairy eyeball. So honeybees have long CD coming out. Not only they have it coming out from between the little segments of their eyes. And so I wanted to go ahead and zoom in on this and we can check it out. The individual lenses on a compound eye are called the ommatidia. Come on, focus, come back. I zoomed in a lot to see if we could see something different, but the focus is so narrow when you zoom in. It's so cool. That's a pollen basket, Susan. So we're looking at a honeybee. I'll go ahead and I'll show you the pollen basket in a moment. I did want to show you this really quick, and then I've got an even better picture. Let's see, it's right here. There you go. So that's an image that I took of my honeybee's eye. That's a stacked image. So I zoomed all the way up to the top of the hairs, and then I took pictures along the length of the hairs all the way down to the base of the eye, and I stacked all the images together so that you can see like the hair almost looks like it's coming out towards you. And you don't get that type of image on a microscope because you don't get that depth of field. So that's a cool thing. Let's go look at its leg. So, is that a bug on its leg? No. That on its leg is a little ball of pollen. So, honeybees have pollen baskets on their hind legs, and pollen baskets are just a region on their leg with longer hairs that are really good at compacting pollen. So as the honeybee is collecting little bits of pollen all over its body, or actually collecting pollen from the flower, they're going to be using those hind legs and kind of rubbing them together and pushing and compacting the pollen into little baskets on their hind legs. You can see how the hairs help keep debris away from their eyes. Of course, yeah, because they're nice and long. But also, it helps them, it's also beneficial for a honeybee to have hairs to collect pollen with, don't you think? I feel like I've seen honeybees where they look like they're absolutely covered in pollen from the front of their head to the back of their abdomen. It's like, you need to go and clean yourself off a little bit, friend. Yes, you can scrape the pollen off and identify the pollen, but what most scientists do, I was actually in a lab that was studying honeybee pollen for a little bit, and what they do is they take a little bit of the pollen off of the leg, and then they break it down into like a liquid, and then they put it through a genetics machine, and they can tell the DNA of the flowers that the honeybee has been pollinating. They like cross-reference all of the genetic code against the plants, and it gets a little bit complicated because I haven't done it myself, but that's what they do is they can collect the pollen, they can determine the amount of pesticides in the pollen, and they can break it down in chemical assays, but they can also break it down genetically. And so you can take a little bit of pollen and take a whole bunch of different data from it. The bug I thought I saw was right behind the eye, though. Oh, let me go ahead and look. I think it's possible. So you might have been seeing the front leg. The front leg is right there, tucked up next to the eyes. I've never tried to identify pollen, so I'm not sure. But, I mean, it sounds like something you could do. You'd have to break it down into very, very fine, I think. Because if you were doing just little bits of pollen off of the body, it might be a little easier than pulling it off of the pollen basket, because it is kind of crunched up all in there together. So I wonder how big the pollen is, like if you could crush it back down, or if you would be injuring its shape. I'm not sure. Oh, okay, very good. I'm glad that we got it answered. And then obviously looking at a bee from the front is really cute because you can see both the chewing mouth parts and the lapping mouth parts. So, honeybees have the ability to chew on pollen, but they drink nectar, because pollen's a powder and nectar is a sugar water. So, up here at the top, right here, we have some chewing mouth parts, and that is kind of like a straw. It's a lapping mouth part right here that they use to drink the nectar. And that's our bonus bee. Hey, have we sketched any other bees yet? I just finished rereading A Sting in the Wild, in the Tail by Dave Goulson. Oh, we have sketched other bees. I think that we did a sweat bee. We definitely did a honeybee. I've done a bumblebee, but I'm not sure if it was on YouTube or not. I think we've done a bumblebee together, too. I think we did. We definitely did a leaf cutter bee. That was pretty cool. And leaf cutter bees, they have a different place that they hold pollen. So honeybees hold their pollen on their hind legs in a pollen basket. Leaf cutter bees hold their pollen on the underside of the abdomen in a hairy region they call the scopa. And that's for leaf cutter bees. Very good. Yay! That'll be great. Alright, so I will go ahead and show you my final sketch. Looks something like this. Oh, I guess I should do it this way. I do it this way sometimes, huh? This is what my final sketch looks like. Yay! I really love these kind of double claws, so I'm gonna have to make sure that this one gets a little bit bigger so that I can get it, so that I can get both of them in. And the other thing that I love about this sketch is that this white line continues all the way around, and then you have the one little one in the center that doesn't touch anything. That makes me really happy. I'm not sure why, but yep, because like this connection and this connection are exactly in the right spots that it needed to happen. So, I'm actually happy enough with this one that I might go and ink it and put it in our book, because I've done a couple of scarab beetles now, but I'm really happy with the overall. So, those claws are pretty fabulous. True story. These guys and the Chrysina gloriosa, they're invited 100% of the time. Alright, so, thank you, Susan, for hanging out with me and chatting all about the line June beetles, learning that there is a whole genus of them, rather than the one species, and they've got cute little eyelashes. I love them. Keep in mind, I also teach on a platform called OutSchool. It's for ages 5 to 8, 9 to 12, and I teach insect studies and scientific illustration for little people. So if you know you have a bug lover in your life, and you want to share that with them, if you go to the description box below, there's a little coupon code for $20 off your first class or two. It's $20 off your classes if you're new to OutSchool. That is just a reminder to subscribe to my YouTube channel, and if you've been chatting here in the box with me, thank you very much, because I know you are subscribed already. Only subscribers can chat with me on in the chat box. So right about there, that's the location for tips. They're always super greatly appreciated. There are a number of you out there that regularly tip, and I super duper appreciate it. It definitely changes. And I have the ability to buy new things for my collection. Like I just got a new couple sets of butterfly spreading forceps. So we're going to be able to spread butterflies with the correct forceps again. And I just got a new ink set so that we can use multiple different depths for the coloring book. So that's been cool. So thank you very much. If you would like to share your sketch with me, or you go ahead and you're posting it on your blog and you'd like to share the link with me, I love to see everybody's sketches that have come out of these workshops or these classes. So go ahead and email me at trisha@theinsectopia.com. And I am on Instagram, although I haven't posted pictures in a little bit. I definitely need to start being better about the social media thing. So that's something I will be working on in the new year, starting tomorrow. All right. By the way, we went to the Caterpillar Lab yesterday. Oh, man, that's definitely somewhere I've always wanted to go. That is so cool. So, did you... do you have to know somebody to get in, or is that, can you pay for tours? I've never even looked it up. hosts free open houses. Oh! Oh, that's so cool. Oh, and I love their website. I have to make my website a little prettier. Very cool. Thank you for sharing that with me. They have open houses on Saturdays, totally free. Oh man, I need to go and hang out at the Caterpillar Lab. That sounds like a blast. Where are they located? Oh, New Hampshire. See, I haven't been to New Hampshire yet. It's just meant to be. Spring break road trip. Actually, my spring break road trip is to California. It's not a road trip, it's a flight. Very cool. Thank you. I'm definitely going to have to put it on my list of things to do. Aww. Come in May for the Carner Blues. Oh, that would be so cool to see the Carner Blues. Susan, is that where you are? Are you in the Albany Pine Bush? Maybe I'll make it a my birthday trip. May is a good month for me. We'll see what happens. Awesome! So, thank you so much for hanging out with me today. And Susan, I really appreciate you coming whenever you do. I see you more regularly, and I absolutely love it. So, and you have a futon? Well, thank you. Go ahead and email me. Maybe I'll email you. Perfect. All right. I hope you all have a wonderful... Thank you. Oh, very good. I hope you all have a wonderful rest of your week. Thank you for hanging out with me. And stay buggy. Have a great one, everyone.